Today I'll be going over how we're going to be using Docker images, Docker containers, and Docker Hub. Right now I have my demo 4 code opened up. You can actually use any code you'd like. It can just be in an app.py file that has hello world returned at a dummy endpoint. But I'm just going to be using demo 4 so that it can be clear on how I can interact with my Docker container later, and that way it will be more clear to you guys. But just as a recap on how our code worked, let's run our demo 4 code. Okay, and it's running, and let's open up Postman. So here I'm going to hit my /endpoint. I can get all my tasks. I can create a task. I can get a specific task, update, you name it. All right, so looks like our code is working perfectly. Let's jump right into creating a Dockerfile. Let me open up my workspace. All right, so let's create a new file called Dockerfile. That's it. No extensions, just capital D and then Dockerfile. So the point that we're using Docker for is so that we can basically package our code neatly into this containerized unit that we can pass along and push to a service called Docker Hub, so that when we get a remote server, basically, I don't know, some server that Google is letting you use in like Texas or Tennessee or something like that, you can pull your Docker image from Docker Hub and run that Docker image as a container. The lecture goes more in depth with this, so if you haven't watched that, highly recommend you watch that first. But this is also great to start with if you are still confused. Okay, so in order to teach our server how to run our code, we need to tell it to pull a base Python image. So it's kind of like, in some ways, telling the server to install Python before they run our code, which is the same thing you guys did when you started writing code. So this is going to be pulling the base image Python 3.7. This is also a Docker image. To give you guys a better idea of what I mean, if I go to Google Chrome, here I just searched up Docker Hub on the internet. The first thing I searched up is the right guy, and it has Python. So this is the base official Docker image. So anytime you want to create a Python application backend, you would just pull this base image and build off of that. So you're building an image off of a pre-existing image. The next thing we want to do is create a working directory and set it as our working directory. What I mean by that is our server is going to have a lot of random folders, and it's going to be pretty empty as well, but you don't want your app.py, db.py just floating among all of the other system folders. You want it neatly inside of your own designated folder that we're going to happen to call app. So let's create a directory. And we're saying create this app directory inside the user directory and set our working directory as this. So what this means is that from now on, anything I do is going to be relative to this directory. So my current directory is user and then app. Okay, so now I'm going to copy all of my code into my server's directory. So I'm speaking as if I'm trying to install everything onto a new server. You guys have been working on your local computers and you already have everything installed, so it's hard to wrap your mind around what's going on. So Dockerfile, your Dockerfile is in the same level directory as app.py, db.py, requirements.txt. Your goal is to copy all these elements and put it in this server's user and then app folder. So now that I've copied that, my server knows what requirements.txt is because I just copied that. So I can run this command. This is the same thing that you guys did when you created your virtual environment, which is install all the requirements so that you can run our demo starter code and so that you can write your own code. And then the final step is we want to let the server know that this is the instruction to run our code. So this is just going to be Python app.py. Caveat is that you can only have one command, so one CMD, but you can have a lot of run statements. And usually you would only set your working directory once and usually only have one base image. So this is a really great, I guess, formula in the future if you guys ever work with Docker images ever again. Again, if you're still confused about why we're using Docker, You can ask a question in Piazza and the lecturer explains that pretty well. Okay, now that we've created Dockerfile, let's actually try and build our Docker image. So right now we're going to build our blueprint. We're not going to run anything. We're just going to build it. So this is docker build-t. Let me just make sure that the command is right. So I'm going to use my Docker Hub username, and then the image that I'm building is going to be called demo, and I'm going to say period or dot for current directory. So the reason why it's the current directory is because I'm currently situated where my Docker file is. So if, so let me just not do this for now. If I did ls, my Docker file is where I am currently. If it wasn't, I wouldn't be able to run that command. So again, it's docker build-t. Great. So you can actually just do docker build-t demo dot, but we want to be able to push this to a repository for your username on Docker Hub. And what I mean by that is if we go to Google Chrome and I click on Docker Hub, here I'm at my repository. So if I just go to Docker, okay, I have to actually go to, okay, so the point is you guys should create an account on Docker Hub. And once you've created an account, okay, that's kind of strange. Yep, once you've created an account, you'll see something like this. You have all of your repositories, and you can see when I was teaching the course last semester, I already created a Docker image called demo, and I pushed it to Docker Hub. This is very similar, if you haven't noticed, to Git and GitHub, that scheme. So you're basically creating something on your local computer, packaging it nicely into an image, pushing it to Docker Hub. Then wherever you are, you don't have to be on your own personal computer. Heck, you can even be on, I don't know, my computer and come over to my house and pull your image from Docker Hub and run your image without having to send me, you know, hey Elena, please clone my GitHub repository and then please install requirements.txt and Python and all of that. So this is why we have Docker Hub and Docker in general. All right, so let's actually build it. And this is just as we expect. So in our Docker file, we have from Python 3.7. So that's the first thing that it does. It fetches the base image, sets our working directory, copies all of our code into this directory. And now that we know what requirements.txt is, we can install all the packages in there. And at the end, it remembers what command to run in the case that we do run our Docker image. And at which it becomes a Docker container. So don't confuse image versus container. Okay, so you can also, instead of doing this, you can say like today's date, like October 24, 2020. I recognize that's probably not the date that you're watching this right now, but you can do that too, and Docker will let you override the latest. So if you don't specify it, Docker will just say latest, but don't worry about that. You can just do this if you'd like. So now that I've built it, I can actually push it. But before I push it, I can also show you guys how to run it. So this would just be docker run. Amazing. So my code is actually running. Let's try and see if we can hit our endpoints. So I can go to Postman. I'm willing to bet it doesn't work for a reason that I will explain to you guys. So one thing is that we have not exposed our port. So if you remember, this is running on port 5000, but our Docker image doesn't have an exposure on that port, or our container, as a matter of fact. And the way that you can fix this is, so let me, okay, so another thing I want to tell you guys is that once you do Docker run, you cannot terminate this until you absolutely close that tab. So I have to close this tab, and I can show you a way to fix that as well. So let's run our thing on our port actually. So let me make this bigger. Okay. So this is docker run -p at port 5000. I want to expose that there and run my Docker image. So now I'm running on port 5000. Let's see if this works. Fingers crossed. Okay. Wow, isn't that so cool? Okay, yeah, so also another thing is I haven't made any requests yet, but I have my data populated already. And that's the beauty of a Docker image is it can even, so it copies over all my database information as well. So whatever I built locally and whatever stuff that my clients sent me, like all of their data, it's all saved. I can package that nicely into Docker image and push it and pull it from somewhere else. Great, so let's see if I can create a task. Let's say make demo 5 video. That works. And if I get all my tasks, that works. So highly recommend that you guys also go through this process of testing your code after running this. So yeah, so let's see. So that one nicely exits out. And that's because earlier when we were just doing Docker run and Elena/demo, it was a daemon process, or daemon, however you guys want to say it. It's DAEMON. That just means that, you know, the process is just going to keep running and you can't Control-C out of it. But the command that I just ran here, this completely works. And that's because of this, -IT, that means -interactive. So it means that you can Control-C out of it. Okay. And this P, by the way, just means port. So I want to run my code on this port 5000. Okay, so now that you guys have digested what the commands are, let's go into a better way in trying to build a Docker image without having to use this this janky port method where I have to specify which port. And the way that you do that is using a Docker compose file. So let's create that right now. Okay. So file, new file, and let's just call this Docker compose.yml. So Docker compose is separated by a hyphen, everything's lowercase, and it's just going to be a YAML file. It's kind of like a JSON file, but not really. It has its own schema. So what we're going to do is, we're going to use, I think, version 3 of Docker compose, so just type that there. And the services that we have for our app, we only have one service, and that's the demo. The reason why people usually have a Docker compose, though, is that people have multiple moving parts to their application code. You might have a backend that processes people's credit cards and transactions, and another part that, I don't know, processes someone's net IDs and fetches all the information about a student and all of that, and then together that's your one backend. But in the context of our course, we're only going to be using one, I guess, container. So Docker Compose lets you orchestrate multiple containers, but we're only using one. And we are going to call that demo. In your assignment, though, I would not recommend calling it demo. It would be kind of strange. So maybe PA5 or something like that would work. And then my image name was demo. Actually, this was my image name. And then I want to define my ports here. So instead of defining my port when I run the container, I can define my port here, and I can do something called Docker Compose Up, which I will show you right now. Okay, so I can do Docker Compose Up. And I'm going to do -D so that I can Control-C out of it and I don't get that weird thing where I have to completely exit out of my terminal. Great, so, okay, how do I know if my server is actually running? Well, I can check it here, and you'll be amazed. So if I do send here, my server is actually running perfectly fine, but it doesn't look like it's running, right? That's because of this -D. So if I did Docker PS, I can see that my stuff is actually running. So if I move my face here and I elongate this, you can see that my container demo1 is actually running. Nostalgic Chatterjee, very interesting. I think this is probably from when we were running it earlier. I didn't actually turn off or kill my Docker process. And the way that I can kill my current process is by running this command. So Docker compose down. And remember, you can only run Docker compose commands when you are in the current directory where your Docker compose YAML file exists. This is the same logic of how you can run docker build -t dot wherever your Docker file exists. So remember that. Okay, so now that I stopped, so if I do Docker PS, you can see that I only have my previous guy that was running. Remember, this was the command that I ran when I did docker run -p quotes 5000 -it instead of the Docker compose one. So it created 2 containers. So remember, even though I had 1 image, I could create 2 running instances of it. You should ignore my Redis one. This is a pet project, so this has nothing to do with the course. But yep, so that is Docker Compose. Also, just to make sure you guys are on the right track and make sure that you guys installed it, you can check your Docker Compose version here, like this. So my Docker Compose version is 1.2/7, 1.27, and the version for the Docker Compose YAML is different from that. So just do version 3. Don't ask too many questions. I think that's just how they version the specific YAML types. Okay, cool. Another thing that I want to show you guys, which will be helpful in the case that you would like to debug, is, so let me make this smaller. Wow, this is extremely long. Okay. Another thing that you guys can do is we can actually step into our container. So if I do Docker PS, so this is technically just like running somewhere on a server, but it's running on my local computer. We can access it. So this is, let me make this smaller. This is a container ID. So let's copy this container ID. Sorry, this is like a lot of zooming in and zooming out. But what we can do is we can say docker exec interactive, the container ID, and bash. And something super cool is you have just entered this kind of like container or this mini server that's running on your computer that you built as an image and just ran as a container. So the root here means that you are admin privilege. You have admin privilege, and if you do ls, look at here. This is exactly what you guys did, where you copied app.py, db.py, recommend the Dockerfile, and all of that. Awesome. Okay. So now that we have done all of that, what we can, let me try and exit. Yep, that's how you exit. I'm going to show you guys how you can push to Docker Hub. So this is as simple as Docker push and your image name. Remember, this should be your Docker Hub username, and you have to use a slash, and this is the name of the image that you're building. So let's push that, and let's await this on Google Chrome. And if I click on demo, once it's been pushed, I should be able to see that it was not last pushed 6 months ago, but literally a few seconds ago. But yeah, let's take some time to wait for this. I guess while we wait, I can also show you guys another command. This is slightly annoying in that if I zoom in, it's very strange. Okay, so I can also do Docker images. And this shows me all of the images that I've built probably forever since the last time I pruned it. So prune means that you clear all the images that you've built. I recommend you do that or else it will take up a lot of space on your laptop. But on Aptiv, I work on Eatery. I also work on Ithaca Transit. If you don't know what those are, you should look into those. We have thousands of daily and monthly active users at our peak, that is. With coronavirus, I'm not sure, but I'm trying to stall. Yes, okay. This has been pushed, and if we refresh this, it says last pushed a minute ago. Awesome. So we successfully pushed to our Docker Hub repository. And remember, if you do not name it your Docker username, it will not show up here. And you also don't have to do anything special on Docker Hub besides creating your account. Just the act of Docker pushing, it will create a completely new repository for you that's named after the image tag that you created. Great. So, I guess that is it for the demo. at our next assignment, we'll be preparing you guys for the hack challenge. So you want your application code or your backend to be able to be accessible by other people that are not just on your local laptop or local computer. So we'll be giving you guys Google Cloud credit, and over there you will have your own public servers and you can pull your Docker images. So how you do that is you do Docker pull. I guess as an example, I could probably pull like student test. I don't know. I could pull it and I could run it. I don't even know if that works, but yes, this is Docker. And another note is make sure that you guys have Docker installed. The way that you know that Docker is installed is if you see this little whale guy and it says that Docker desktop is running. And then you can make sure that you've signed in if your username is right here. And these are my organizations. Okay, alrighty. Good luck, guys, and see you at the next lecture video.